Hello, everyone. Welcome back. Welcome to this webinar. Today, we are going to talk on a very important subject of integration of CIMCO Edit 2022 inside SolidCAM. CIMCO Edit is something, or rather, CIMCO is not an alien word to all the CNC people, or rather, it's not an alien word, alien word in CNC manufacturing. CIMCO is an integral part of almost every CNC programmer's computer, whether it is a small job shop or even large organizations, they use CIMCO. Most of the time, CIMCO is used as a standalone product. But of recent, we have seen like in SolidCAM, we have started this tight integration between CIMCO and SolidCAM itself. So if you ask me, personally, I've been using CIMCO since probably ever since I started creating CAM programs, because I use CIMCO for two reasons. One, it's the most reliable backplotter available today on the planet. It's very easy and it's very reliable as far as backplotting goes. Second, it can catch errors probably are not which are not visible in the CAM systems, because probably there could be an issue with the post processor that could have generated that error, or some other thing. But these errors are generally caught by CIMCO straightforward when you're running the simulation. However, all these years, so as a standalone product, it was really very difficult. It needed a lot of work to do to get CIMCO to actually do a backplot. Most of the times, people were more comfortable in running or just taking the G code and looking at the backplot of the G code on the screen, without the ability to do any kind of simulation or anything. Maybe the tool used to run, but it was not very powerful enough. Of late, CIMCO has also become really very powerful as far as backplotting a G code is concerned, editing a G code is concerned, or even simulation. So the agenda for today's webinar is basically to explain you what CIMCO Editor is. We'll also dive into our NC functions, look at the file compare capabilities. We may not touch up much upon the file comparison, but we are going to spend a lot of time in the backplot, because uh, all these years, even me, I have been using CIMCO not to backplot really 5-axis toolpaths, but to backplot simple 3-axis toolpaths or the die-mold toolpaths, which were very easy to backplot and catch errors. But we are going to spend some time today on the backplot of 3+2 and simultaneous 5-axis programs, and not only just backplot, but also run the simulation with everything inside the CIMCO window. And the last one is really not very popular, because the transmission of CIMCO, or the help that CIMCO does for transmitting the programs, is more valid to older machines which do not have the capabilities to read in via a memory card or via USB. That's where CIMCO comes in handy as a DNC tool, or a direct numerical control tool, to transfer programs from your PC to the controller, what we call as a drip feed. Okay, so we are going to touch upon also on the transmission front. Right, first of all, why do we need CIMCO? We have uh, we have our own solid verification in SolidCAM. We have our machine simulation in SolidCAM. We have HostCAD in SolidCAM. So why do we need another simulator like CIMCO? Simply one answer to this. Any CAD/CAM software or any CAM software, when they run the simulation within their own environment, what they're actually basically doing is they are simulating the cutter location path and nothing else. So first of all, there is no idea of the arc. You don't know what an arc is inside the CAM system, because it's only plotting the points of the toolpath, which they call as a cutter location, or which we call as a cutter location path. So what you're actually seeing in the CAM system is basically the CL point movement, or tool moving on the CL points or cutter location points. Most of the times, this is not exactly what happens on the machine, because between the CL point and the machine comes another interface, which we, in our terms, we call as a post processor. Now, the post processor can sometimes go crazy. You can have wrong outputs. Something is written wrongly in the post processor, and most of the times the wrong output doesn't happen for linear passes. Most of the times the wrong output comes for the arcs, and that is really very dangerous, especially when you're trying to run, let's say you're trying to run a tool, a 10 millimeter deep depth of cut, and it's cutting very nicely, and suddenly one of the arc that is output by the post processor is reversed. Instead of doing an outer circle, it makes the inner circle. That's good enough for you to ruin your job, your tool, everything. And because the CL data point cannot catch this error, you need something outside which can analyze and catch these errors on a G code, not on a CL data. And this is where exactly CIMCO Edit comes into play. It is very popular. I can tell you CIMCO is very, very popular. It has close to 1 million licenses today worldwide, and I'm talking about legal licenses. We don't know, probably I have no idea of how many illegal licenses of CIMCO are there, probably thousands and thousands and millions maybe. But it is very popular because it's been around since 1991. So it's like almost 30 years since they have started working on the product. So 30 years is a long time for a backplotter to be very reliable and very strong. So we have two options here. One, CIMCO is used for editing the G code. It can be used for comparing two NC files. You can visualize the G code by backplotting the toolpath from the G code, and of course, sending the G code to the machine. Most of the times, CIMCO is used to catch errors in G codes. Okay, so that's the primary function of any G code simulator. It's to catch errors, it's to catch issues before they happen on the machine. Simple 3-axis toolpaths, generally people don't, but I have been working with 3-axis toolpaths for the last 27 years. Even today, before it goes to the machine, I just put it through CIMCO, because once CIMCO clears it, I know that we are not going to have any issues on the machine straight away. So the whole idea of CIMCO is to check for collisions in, or check for issues of the G code in the NC file. Sorry. So CIMCO Edit 2022 versus CIMCO Edit 8, because 2022 is the latest version. As far as SolidCAM's integration with CIMCO 2022 is concerned, we have finished. You can see almost everything. The only thing that is not implemented, which is in process and should be implemented in the next month or two, will be sending the information of turning tools into CIMCO Edit, sending information of STL holders, and then the tool identification for VMID for turning, sending multiple targets and multiple stocks to CIMCO. Apart from this, a very, very interesting thing is coming up for CIMCO 2022 in another couple of months, and that is to take your entire machine model and do a machine simulation of the G code exactly as it happens within the environment of CIMCO. All of this is just a one-button task from SolidCAM. So that's where the whole difference uh, is between working with SIMCO on a standalone basis and working with SIMCO inside running with SolidCAM. So the integration here is the key. Uh, Looking at the functions of the editor, most of us know how this editor works. Basically, it highlights certain G codes in a certain color. For example, it'll highlight your absolute mode and incremental mode in a particular color. It will highlight your rapid and linear moves in a color. It'll highlight arcs. It will highlight the cycles, basically the CAN cycles, and you can add cycles, you can remove cycles, you can modify cycles without having to go back to the CAM system. But of course, if you ask me, should I do that? My answer would be don't do that. You use SIMCO only to backplot and check, but don't try to do any modification. Of course, there are some experienced programmers who do that, but frankly, I don't touch most of the editing functions. But you have got a great amount of editing functionalities which you're going to see today. In fact, there are some editing functionalities which are like amazing. You don't actually need to get back to the CAM system to do all that. Uh, some nice color settings. For example, you can put rapid moves in a certain color. You can put the linear moves in a certain color. If you are having a G2 arc, you can put it in another color. G3 arcs can be put in a different color. You can do a lot of things, and then you can search. Now it's almost like a text editor, but a very, very advanced text editor. For example, I can search a tool change, so it precisely knows what it needs to search, rather than I having to type search for M6 T1 or T1 M6. So I don't need to do that. I just keep clicking the tool change, and it knows precisely where the tool change is. The NC functions, again, like I said, the editor is a very, very advanced editor. For example, you can add or remove the the block numbering. You can add or just remove them out completely. You can increase or decrease the RPM without even having to go and edit at the block. Just you can click on the adjust spindle speed, and you can say, I want the spindle speed. It will find wherever that spindle speed is, it will increase it by that particular percentage. You can also increase feed rates without having to change every block. You can just say, make it 110% of the existing feed rate. All the blocks where there is a feed rate will automatically change to 110% of the programmed feed rate. You can create quite a few reports coming out of SIMCO. You can create the tool list from the entire program. You can create toolpath statistics, which basically tell you the envelope of movement for each tool. And then you can say, I would like to create a report of this entire tool list with the envelope movement and the timing. So it will create a text file, and you can use a text file to print or send it down to your shop floor, basically. We have a function that can compare two, SIMCO has a function, very nice function, that can compare two identical files or identical looking files and tell you where the differences are. If it finds the difference, then it'll highlight at which level the difference is and what is the line that is different. So it's basically like it can take two NC files and do the comparison. Backplot is the most important thing which we are going to spend a lot of time on, and I will, rather than explaining it to you on the PowerPoint, I would like to explain to you on the in the software itself. Now, one of the most important things of working with an integrated version of SIMCO is that you, as a user, you don't need to call anything. Like if it happens, like it happens on a standalone CAM system or a standalone SIMCO system, you'll have to first load the G code. Then you need to go to the fixtures, load the fixtures, find exactly where the fixture is going to be located. You need to know the distances. You need to call the target manually. You need to call the stock manually. You need to define your tool and holder manually. So this itself is a big work, big job. And In SolidCAM, or the integration with SolidCAM, all of this thing is done with just one button. At the time of generating the G code, everything else is collated and sent to CIMCO as one single file. And CIMCO, when it opens, when I'll show you, you'll see that everything comes in its place. The tools exported are also with the holder, with every parameter. Now, the only thing that is missing in the version that is currently released is the export of STL holders. We will release it very soon, where you can take STL holders and export them to CIMCO. Of course, people know that once you select a point on the toolpath, it gets highlighted back onto the G code where it is. Then the most important thing is the transmission. Like I said, people don't use CIMCO these days to do the transmission, but for people who are my age will know this photograph. And CIMCO was probably one of the earliest DNC systems to actually recognize the need to send programs, because earlier, before the DNC systems came up, we had these tapes, and the earlier tapes where the codes used to be punched, like few kilobytes, used to be a huge tape, and the tape used to be taken to the machine, and the machine used to read from those punched codes what was the NC program. And then came the magnetic tapes. Okay, DNC was a big leap when it came to sending programs to the machines, because older machines, like 10-15 years back, old machines did not have the ability to read from a USB or Bluetooth, or even even Ethernet. Ethernet was the next step, but before that, these were the ports that were used to send programs from your computer to the machine. And it was really very slow, because there was something called as a baud rate, or the speed at which the serial port. Now, this particular marked port is the serial port, and the one in the pink, this one is the parallel port. So CIMCO had the ability to use either one of these ports and communicate to the machine using these ports. Now, these ports in those days were considered to be very fast, but now when you are sitting at your home with a broadband speed of 1 gigabytes per second, you will realize that this is like almost not even crawling. It is like sending, it's like ants moving on the floor. That is the speed when you compare it, because the baud rates at the time were like 9,600, 19,200, and 96,400, or 1 lakh, or 192,000 uh, bits per second. Okay, I'm not even talking of kilobytes or megabytes. We're talking of bits per second. So you can imagine what was the speed, but it did its job at that time. And CIMCO, even today, helps us to communicate with DNC, these old machines of DNC, using these ports. Now, if you look on your laptop, you perhaps will not find these ports. They are already obsolete. But if you go to stores like Amazon or Flipkart or any other online store, you get these converters where you can connect to USB, and you can get a serial port converter from USB to serial port, and you can use these to communicate to the machines. So I'm going to touch upon a bit about this also. Transmission basically is defining the machine inside CIMCO with all the proper parameters. Now, these parameters can be taken from the controller itself. Fanuc has got a very specific area where these parameters are displayed. You can take those parameters, put the same parameters here, and only then the handshake happens between the computer and the machine, or the controller rather. And then, of course, you can send. Now, when you're sending the program, we call this sending drip feeding. If somebody knows what is drip feed, it means it will trickle down. It will send 100 blocks. It will wait for the machine to finish running 90 blocks. So when that memory is cleared, it will send further more 90 blocks. Okay, so it used to work, or it does work in the older machines, but for the newer machines, this is really very slow. You will see that if somebody is using DNC to send program to the newer machine, the machine will actually wait for the program to come in. Okay, so it's more meant for the older machines. Right, so let's get into the product. Now what I'm going to do here is I've taken up few files, and I'm going to use few files. For example, I have one 3+2 file, a simple 3+2 file, one 3-axis file, one simultaneous 5-axis file, and one Swiss type file, just to show you the multi-channel backplot. Okay, so let me open, first of all, the 3+2. So I've got a pretty simple part where I have some face milling from the top. I have also face milling on all the 4 sides. And then there are some pocketing operations from every side. Okay, so it's pretty simple. The part is pretty simple, and we would like to look at the backplot of this entire thing. Now, how it works in CIMCO, the first thing that we have to do, most of the times this is very puzzling for people who have started using CIMCO straightforward. It was even puzzling for me why it was not working, because 3+2 is not a straightforward toolpath to backplot. So in SolidCAM 2021 SP3, in the VMID, we need to go to the working style and go into the CIMCO editor configuration data. And we need to set these two values. For example, how does CIMCO identify the tool identification, or how does it identify the tools? There are two methods in which it can identify. One is using the tool number. The other one is using the tool ID. Okay, the description is not really there, but tool ID and tool number are the two areas that it will use to identify, or this is what is sent to CIMCO. The other thing is the machine configuration. Which machine configuration? When I say machine configuration here, I would specifically say the controller configuration. So I have to set what controller am I going to use to send this data to. So when I click here, I get several options which are already set inside my CIMCO function. If you have not set this in CIMCO, you'll not see many here. Okay, you'll see Haas, you'll see Heidenhain, and you will see, let's say, text file. The other things we'll have to add, and I'll show you how we add it. So since I'm using a Mazak Variaxis i500, I would like to use the Mazak, the Mazatrol control configuration. It's either Mazak, Matrix, or Mazatrol. So I use that configuration. Save this, and all I need to do now is to click on G-code all. Oh, before we do that, we also need to go to our settings, and in the G-code generation, we need to set the editor for G-code generation. Okay, there are, by default, the editor is always the notepad function in Windows, but you can also set the path of where my CIMCO editor is. For example, it's C:programs, SolidCAM 2021, SolidCAM, CIMCO editor. So if I go to, let's say, C drive, and if I go to my program files, SolidCAM 2021, SolidCAM, CIMCO editor. So this is the path, and I have my CIMCO editor here. If somebody runs this, we'll get an error. Okay, that's because the license of CIMCO is linked into the license of SolidCAM, so you cannot run it from outside. You will have to run it only when SolidCAM is open, and that too from inside SolidCAM. So if you are trying to run a standalone version of CIMCO, don't try to run it from here. If you want to run from a standalone version, you go to SolidCAM here and click on CIMCO Edit. It will only run from within the software. Okay, this is an absolutely legal license. You can see that it is supported by SolidCAM's standard key. Let me kill it. Okay, let's move. I'll right click on the operations. I'll click on G-code. I'll say generate. Okay, it's asking me the string. Okay. Once the G-code is generated, SolidCAM then converts the fixture the part, the workpiece, the stock, the tool, including the holder and the G code, and sends all this information to CIMCO. So we have all this information here, and this is my G code. Few settings that we need to do here when I go into my global setup inside CIMCO is select the scanning, and you would like to scan, or you would like CIMCO to scan the setup file that SolidCAM is sending. So what all does the setup file contain from SolidCAM? It contains the geometries, it contains holders, it contains stock, it contains tool, and it contains the work offset information. All of these function, or all of these information is scanned by CIMCO from the setup file that SolidCAM is sending to CIMCO. That's one. The second thing, you saw that when I went into my VMID and I went into the CIMCO configuration, I had several controls. Now you can set those over here. For example, these are all my machines. You can add more machines. For example, I can add, let's say, Humle. So this machine will have backplot on machine simulation, NC functionalities, including syntax highlighting, NC assistant, and NC autocomplete, and basic editor functionality. So now it's asking me, what is the type of this machine that you just defined? So it's going to be a milling machine. And then I need to define which control this machine is having. So I'll say my Humle has ITNC 530 or 640 control. And I'll say, OK. So I create a Humle machine configuration here, which has got also the controller definition. This is basically for reversing. So this is the place where we configure our machine configuration, which is basically the controller configuration. All right, so since I used Mazak here, I have got, you can see that it automatically picked up the Mazak machine configuration, which will in turn pick up the Mazatrol or matrix control, depending on the G code that is there. Few things about the NC functions. For that I will do, or I will open another part. The next item is to go into backplot, and in the backplot, before we actually click the backplot window, we need to do some setup. So I'll go into backplot setup. It's asking me to select the machine. Now by default, CIMCO gives you quite a few number of options. Okay, it gives you several options of the machine. If you don't find your machine and you would like to define your machine, for people who are already doing machine simulation, this will be a piece of cake. They can simply go to the add new machine function and either copy one of these files or just add a new configuration. Okay, so once you add a new configuration, all you need to do is to provide the axis, how they are, which axes are on the head, which axes are on the table, and for each axis, what is the movement? For example, if it's a linear axis, what is the minimum maximum movement? What is the feed rate? And if it's a rotary, then what is the minimum maximum values of the rotary? And if it needs to go to tool change, I need to provide the sequence, which is going to be the first sequence, which is going to be the second sequence, which is going to be the third sequence, and at what value the tool change happens on the machine. So this information I need to provide to CIMCO, and only then the machine will be taken up. Okay, so once the machine is picked, say okay, I can then go into my backplot window and wait for CIMCO to load all the information. So what it has loaded here is on the right hand side. Okay, let's zoom in. It's loaded, first of all, the machine origin. It's loaded my G54, which is my work offset. Again, it's coming from SolidCAM. It's loaded the fixture. It's loaded the workpiece. Currently, I've hidden it. And of course, it's loaded the stock. All this information has come directly from SolidCAM. I did not have to ask, or I did not have to call this information anywhere, because what it did was it went into this global setup function and it scanned the setup file for geometries, holders, stock, tools, and work offset. Right, so let's zoom. And I can just click on backplot again here, and we can go into the tool setup. So when I click on tool setup, again, it's going to scan the entire NC functions, and it will show me the tool that are being used here. So there are two tools that are being used. This is tool number 9, and you have tool number 10. You can see every information of the tool, including the holder and the cutting length and the out of holder, what is the diameter, everything, all this information came directly from SolidCAM into SIMCO. I did not have to define anything in this. Okay, this is from SolidCAM. So I've got a tool setup. I can hide or show the tool path, sorry, not tool. And what you can also do in the NC functions, as a part of NC functions output in SIMCO, is that you can make two things. Sorry. You can make a tool list. So I can just click on the tool list. It will immediately generate a text file for me. It will tell me the file, program, and the path, and when it was created, and it tells me the tool number and the information of the tool as it received from SolidCAM. So it can do this information. If I go to the toolpath statistics, it tells me the entire statistics of the toolpath. For example, it will tell me what is the minimum X, minimum Y, minimum Z, maximum X, maximum Y, maximum Z, and the time taken for machining. And for each of this tool, I can further detail it down on what is the machining time, how much is the cutting time, what is the rapid time, how much is the dwell time, tool change time, tool path length, cutting length, maximum feed rate, minimum feed rate, width. A lot of information is given to the user. Okay. Now the main information here can be exported to a simple text file. So I get for tool number 9, what is the minimum X, what is the maximum X, minimum Y, minimum Z, maximum Z, and the tool cutting time, which includes, of course, also the rapid time. Apart from this, let's get back to my back plot and select the play button. Now observe what is happening. It's actually taking my tool and it's showing me the cutting. Now, very important thing, what it's also doing here is it's read this particular line, G68.2, so it understands. It understands 3D coordinate rotation. Coming from the G code, it understands the 3D coordinate rotation, and we can continue. So it's already done. However, we can see that I have a problem here. It's shown me that there is a collision. I don't see this collision anywhere on my toolpath. Neither do I see this collision anywhere on the on my G code. So where did this collision come from? For a couple of weeks, even I was very puzzled when I used to get this collision, and most of the times I used to ignore it, saying that there could be some problem. But there is a mathematics behind it, and we need to fix that. In SIMCO, or this backplotting and simulation, backplotting is fine, but when you run the SIMCO in the background is actually running the machine simulation of SIMCO. So it needs to have the machine information. Now, where is this machine information coming from? The machine information is coming from the backplot setup. I've used this machine, DMG 65 monoblock, with the Fanuc control because the construction is more or less the same. So when I go here and look at my C-axis, I have a center value of minus 325, minus 325, and minus 610. This is basically where it is saying that this is where my C-axis center is. And similarly, I have got my A-axis values also here. Now, as SolidCAM, let me kill this. Let me go into my VMID and let me check where in my station coordinate system these values need to be put. So I need to put those values here. So minus 325, minus 325, minus 610 is the value that I need to put. Or whatever is your machine values that are there in SIMCO, those same values need to come also in your VMID. Otherwise, you will have a mismatch on where the machine 0 is, and you will get wrong results coming from SIMCO showing collisions where actually none really exist. So you have to be very, very careful here. So what I'm going to do here is I'll just go to C colon GPP, and I'm going to go to that particular VMID. So that's my VMID. I'll go to C drive, or rather C axis, station coordinate system, and I will enter those value here. So minus 325, minus 325, then minus 610. This is where my home position is, or this is the position of C axis from the home position. Oh, save yes, please. Minimize. I will reload this file. And just run the simulation again, or run the G-code again. Now, since I've put everything, I can see that it starts giving me the limits error. Okay, because my other items are not set, but I'm going to ignore them for a moment. Again, back into SIMCO, backplot. I'll just verify if it's the same machine. It is. Go into the editor. Controller is Mazak. Again, back to backplot. And if I go to backplot window again, everything will be back as it is. Now you can see you've got much cleaner movements, which we're not going the other way, going underneath it or anything. You see a much cleaner movement. I'll switch off the toolpath. And now let's run the simulation. Perfect. See, no issues now. Clean, my toolpath is fine. I can now go with full confidence that I won't have any issues on the machine because I have verified this toolpath. From a SolidCAM technical team perspective, you can actually use this wonderful tool to actually test your post processes also, test your machine simulation also. Okay, so a very powerful tool, first of all, to verify your toolpath without breaking any kind of sweat. Rather, if you go into the standalone versions of SIMCO, you'll have to do all these manually. Bring in the G code, bring in the work offset, find where the work offsets are, define the stock by yourself, define the workpiece by yourself, define the tool, define the holder, everything you have to do manually and then run the simulation. And if one of the thing is wrong, you repeat the entire process. So it greatly saves, the integration greatly saves the time for your G-code simulation. And if you ask anybody, SIMCO today is the most popular and most powerful G-code simulator that's ever built. Okay, quickly, I'll open another file because I would like to show you some NC functions. Very nice, very popular NC functions. I mean, if you're an experienced programmer, you'll love it. So I have a bracket here, and I've used the automatic 3+2 roughing, and I've generated this roughing using my auto 3+2. So what I'm going to do here is I will generate the G code and take this into SIMCO again. Pretty lengthy program, so we need to wait for a minute. Okay, I have the file, NC file, everything is out here. It's a Hermle, so it's a Hermle C30. So automatically, because I had set it in the VMID in the SIMCO settings that needs to pick up Heidenhain. So it's picked up a Heidenhain controller. And if I go into my backplot setup, I have picked the nearest machine because I don't have a C30 defined here. So whatever was available to me, I picked a C42, which is a similar looking machine. Same, just a bigger size. Say, okay, let's go into my backplot window. you'll see where did everything disappear. You can see here it's scanning the NC data, and everything is in. So I will switch off the toolpath, and I have the part here. Okay, let's regenerate this. Sorry. Okay, I didn't see that it was regenerating. I'm so sorry. So you can see that it not only understands the G62 68.2, but it also understands the tilts and other things from Hide and Nine also. So you can run safely and check what is happening exactly on the machine. We'll wait for the simulation to get over, and then we will run some nice looking NC functions on this. By the way, this calculation is completely automatically done, so I didn't have to define any plane or anything for this. It just took the part as it is and machined it from every side possible, automatically taking the directions. Right, so it's done. We can also see that the quality is also good. You can control the quality using the solid setup here. You can go between low resolution and a pretty high resolution. Okay, so I'm going to go back again to my toolpath. I would like to look at the toolpath. Now you can see that this particular side is on this side. Now, in NC functions, we have got some very, very interesting things. I'm going to close the backplot. In NC functions, I have got some very nice functionalities. The uh, the main functionality is why a CNC programmer would need this is, let's assume I want to mirror this entire project or entire toolpath. I can CIMCO offers a facility to mirror this entire thing, including if it's an entire project. So if you have 15, 20 toolpaths or even 100, 200 toolpaths, you can mirror them just at a click of a button. So I'll go to the NC functions called mirror. And here it's asking me the mirror functionalities. Now, the functionality here is a bit tricky. So what I'm going to do is I'm just going to take my drawing tablet and explain to you what these are. So let's go to the whiteboard. Oops, that's not going to help me. So I'll go to a snip. Fine. So it's asking me what is your point here, XY point, and what is the angle. Generally, when we go into mirror, they will ask you what is your plane and other things, but here it's slightly different. What CIMCO considers is if this is my X and this is my Y, it's asking me a point on either X or Y. If I say my point is X0, Y0, it assumes, and if my angle is 0, it assumes that my plane is normal to Y. Okay, it's this plane. But if I put a value here 90, it means my plane is here. This is my plane. Or if I put some value here, so if I say Y20, so it will take this plane, offset it by 20 mm, and this is going to be my mirror plane. If I put X20 and Y20, doesn't make any sense. It has to be either one of them. If X20 and if it's 90, then my plane is going to be here. So all I need to do is to enter these values. So this is what we are going to do. Let's keep the table back. So it's going to be X, Y, and I'm going to mirror it around Y axis. So I'll say this is 90. And we will take the result into the new window. Okay, so I have my mirrored program already ready here. If I go into my initial program, if I go into my backplot window, because I would like to show you on which side that particular taper is, so that you will realize on which side I'll hide the stock, and let's zoom. The taper is on X minus. Now, because I have mirrored the program, you'll see now the taper would have moved to X plus. So I'll go again to my mirrored program, go into my backplot, click on the backplot window. Because I've selected the scanning on, so it's scanning the data. And what happened here was I got the taper on my X positive side. It was on X negative, now it's on X positive. So I have mirrored this program without going into my CAM system by just simply setting the plane in CIMCO and mirroring it. Now, the best part of mirroring it inside CIMCO is that it need not be only one program. You can have a group of programs and you can mirror the entire programs using CIMCO. It could also mean the entire project. So if you have set only a single G-code, you can mirror the entire G-code in one button. Okay, one thing was about mirror. Now, you can not only mirror it, but you can do several other things. For example, let me close the backplot window. Let's go to the NC functions. Let's hide this. We can also rotate the program. Okay, so I can say my rotation point is at x0, y0, but I would like to rotate it at 45 degrees. Okay, result again to the new window. I don't have to go back to my CAM system to do all these things. This can be done straight away on the so again, if I go to my backplot window on the rotated program, you'll see if I go into my G17 view, my program is already rotated. This is my X. Program is rotated by 45 degrees. Imagine I'm rotating a 5-axis program. So rotation is also at a click of a button. What else can we do? We can change the feed rate. We can adjust the feed rate. You can simply go in here and you can say, instead of 100%, I would like to have 110%. Click on apply. All the areas where the feed was 100 changes automatically to 110%. Of course, you should not have a parametric feed here. Okay, it doesn't understand yet the parametric feed. If it's a non-parametric feed where the feed rates are appearing, it will find those feed rates and change it. You can adjust the spindle speed. You can say I want 125% of the spindle speed, and you can change it. Okay, again, this will change straight away. All right, so you can also do translate, move the program. You can add compensation. If your program doesn't have compensation, then you can add compensation to the program. Mirror we just saw. Now the best part, what I like here is, and this is more meant for 3-axis and not really for 3+2, is that you can convert at a click of a button a hide and hide program to an ISO program. So it removed all those commands that are actually calling hide and hide functions, and it converted them into a simple ISO code. And you can do it otherwise also. You can convert it back from ISO and you can change it to hide and hide. If you have an ISO code, you can quickly generate an hide and hide code or .h program. We are back again. Okay, right. So that was about the functions with CIMCO. What we will do now is pick up another file. So I'm going to open let's say a multi-blade or an impeller. Apart from backplotting 3-axis or 3+2, SIMCO can also backplot simultaneous 5-axis files. Okay, so let's say if this was my floor machining program, and let's check what was the tool used here. Okay, it's a taper ball nose. So I generate the G code, say okay. Now it starts updating the stock. I don't want to see the stock, so I'll kill the stock here. Process. Again, you can see that my file is loaded. It was Heidenhain. If I go into my backplot setup, it's Humley. Okay, and go into the backplot window. You can see my fixture, which is a chuck that's holding my impeller, and the toolpath itself. All I need to do simply now is to play. Clean. This is a great tool for you to visualize your toolpath before you take it to the machine to avoid any kind of surprises that might arise on the machine. Once SIMCO has cleared it, trust me, 100% of the times you will not have any problems on the machine, unless there is some error in SIMCO that has not found the problem and it's just escaped your scrutiny. So apart from 3+2 or simple or 5-axis, of course, for people who are into mold and die, can actually take their entire part, whatever they have programmed, and again do the backplotting or using the G code. So whatever changes of the G code that you do are dynamically updated on the part itself. So if you make any changes to the functions, you will see that the backplotting will start running again. Okay, this is a pretty huge part, so I'm just waiting for it. So I have this part with all my programs, so I can just go to the first one, not the simulation, I'm so sorry. I'll run the G code from this. Okay. Let's go to backplot, go into backplot window. Part is loaded, the fixtures are loaded, the stock is loaded. So I will switch off my target. I'll switch off my toolpath and I start the play again. So you can run the backplot of even and basically simulate 3-axis toolpaths. Okay, also very quick. Right now I've set the solid setup as low quality resolution, but you can also set it at a very high quality resolution. If your machine is very powerful, you can do that. So the summary of this entire exercise is that you should have a G-code simulator like CIMCO sitting outside on your system, which will help you identify problems, which will reduce the errors that happen on the machine. And for people who are developing post processors can easily check their code even before they send it to the customer, whether it's working or not, because CIMCO supports almost every controller that is there today in the market, whether it's Heidenhain, Siemens, Mitsubishi, Mazak, Fanuc, or other controllers, Okuma. All those controllers are supported by CIMCO. Right. That was a quick run up of our integration with CIMCO. You can see that it's really very powerful. One button, push the data into CIMCO. You can check your G codes, run the simulation, and you can be 100% sure of your part coming out right on the very first attempt. So you can check everything here and then take it to the machine. I'm sure it'll be all right, all perfect. If there are any questions, I would take the questions. Uh, Gregory is asking if SIMCO is integrated in SolidCAM and licensed through SolidCAM, or you need to buy it from SIMCO reseller to access full function. No, Gregory, you can you can, because this is coming or it's licensed SolidCAM. Of course, you need to buy the SIMCO Edit from SolidCAM so that integration happens. You get the integrated version basically from SolidCAM itself. You don't have to go to a SIMCO reseller to buy SIMCO. It will come directly from SolidCAM. Okay, I'm sorry. Somebody asked about the transmission. So I would like to quickly touch upon the transmission. So, sorry. When I go into my DNC settings, or basically when I want to transmit to a new machine, I need to add that machine. So let's say I'm adding a machine called ABC, and machine template configuration is machine 1. Okay, my current laptop doesn't have any serial or parallel ports, and that's the reason it's unable to locate anything here. But if your computer has serial or parallel ports, it will show you the list here. Basically, you will see COM1, COM2, these are basically the serial ports, LPT1, LPT2, these are your parallel ports. So you need to select the port. And once you've selected the port, the stop bits, parity, baud rate, and data bits information will come to you from the controller. You will have to go to the controller. Probably the machine builder himself will tell you, or if the machine builder is not there, sometimes the machines are very old, you will get this information. Generally, if it's FANUC, then you'll get it from the FANUC parameter settings. There is I forgot about the place where you find this, but in the bit settings, you will see the DNC settings where it'll tell you what current stop bits are set, what is the parity set in the controller, what is the baud rate. It's very important. You've got several options. 9600 generally is a standard. This is the slowest baud rate. General one is 19200 or 115200. These are the baud rates that are set on the controllers, and then the data bits. So this information will come to you from the controller. Once you have set this information, you can then select the machine and then transmit the data to this machine. You can select this and send this data. You'll see a handshake happening on the controller. Just below that, below the place where you have got the access information, you will see a blinking sort of happening that it is receiving data from the DNC. And once it receives enough data, it will show up in the NC memory. It will show the program on all the blocks that have been received, and you start your machine, and the computer will start drip feeding as and when the blocks are emptied on the machine. Now, DNC is a very, very dangerous setup, especially if your DNC cable is running next to a voltage transformer or a stabilizer. If it is running on top of it, or it's very close to the voltage stabilizer, and if there is a fluctuation in it, there are every chances that when that program is getting transmitted, you can have errors in the code itself. We have seen this. I have had very bad experiences with DNC when my code uh, was plus some value fluctuation, one of the digits disappeared, crash on the machine. So as far as possible, please avoid the DNC, but if you cannot, and if you can ensure the cable is running very safely to the machine, go ahead. There are new generation DNC today. They don't go using cable, uh, or rather the programs are not sent through cable. They're sent through wireless. They have got a device that is attached to the your computer, and you see a transmitter, and the machine also has got a receiver, so the data is transferred wireless. Those are much safer areas. Those are much safer devices to transfer data using DNC. Okay, let me see if there are more questions. I think I just answered the DNC. Does SIMCO understands parameters in G code? It understands the the G functions. It understands the M functions given for the particular control. If there is any other special functions, for example, you can see here there is a word called, there's a German word, Drehung. It doesn't understand what that is, because if I go into my navigation window here, sorry, the simulation window, it tells me all the errors, syntax errors that have occurred in the NC file. So it says it just doesn't understand what this Drehung function is. So it says it has ignored the command. Probably because I have an English version and the post processor is from Germany. That's why this mismatch. So if there are certain functions that it cannot understand, it will put it in the simulation error window. You can see there what is the action that it has taken, whether it has done something, whether it has deleted the line, whether it has ignored the line. It will tell you all the actions that it has taken here. Of course, those blocks will also be marked by CIMCO. So it doesn't understand what is M52. It doesn't understand what is M31. So these blocks are ignored by CIMCO. Is there an option for numeric controls? Of course, yes. If you go back to NC editor, and if I go into the global setup, you'll see that in the machine configuration, if I add any machine, for example, if I add, let's say, DMG 50, and if I say this is a mill, in the control type, I have an option here for Siemens 840 DSL. Even the version of that particular Siemens control is addressed by CIMCO. So I can select the CIMCO control from here. Let's check if is it possible to customize CIMCO's reverse post processes? I don't think we can do it. This is something that CIMCO only can answer. But yes, for example, if you want them to start supporting these M functions, then yes, we'll have to get in touch with CIMCO and get these commands input into that, and they will probably send us a new controller definition file. SolidCAM. Where can I find controller types that are not listed like Herco? Okay, controller types that are not listed by CIMCO, you'll have to get in touch with us, and we will get in touch with CIMCO and try to get this controller definitions for you. Does it understand parameters? Boaz, it really doesn't understand straightforward parameters, but most of the things that Siemens, for example, supports, if I go into, okay, I need to show you another window then. So if I've selected Heidenhain here, and if I go into my NC functions, and if I go into my, not this, so it shows you all that is there with Heidenhain that it supports. Okay, all the M functions which Heidenhain is having are listed out here. These are the functions that is supporting. Now, if this is anything else, the parameters, anything else other than this, then we'll have to get it done, or it's almost like a customized function for you. Similarly, for Siemens, if I close the backplot, if I go into Siemens here, so if I go back again to my backplot window, and see function, sorry. So if I go into Siemens, you can see all the functions that are supported by Siemens, supported by CIMCO uh, related to Siemens. So these all functions are basically supported by CIMCO from Siemens. If there is anything missing, please let us know. We will let CIMCO guys know it, and we can get these things added from their side. Does CIMCO save the configuration received from SolidCAM? No, it doesn't save any kind of configuration. It could be somewhere inside, but it doesn't take a big task to re-export everything once again. You're talking about using the hash parameters. Yes, it does support hash parameters. I've seen this in the macro. You can have the hash values supported, but I think I've seen this only with Fanuc. I've not seen this with Siemens. Right. I think more or less I have answered the questions. Uh, if there are more questions, you can always write to us. You will get an email because you've participated in the webinar, so you'll get an email directly after your participation. You'll also get a link to view this recording because it's being recorded, and you will get the link to view this recording directly from our website or YouTube link, whatever it is. So thank you very much for your attendance, and have a great day. Thank you. Bye-bye.